We're going to start looking at how to factor. There's many options and many ways that you can factor, many methods. Each method that we learn about is going to have a specific role or a specific time when it should be used. The first method we're going to look at is factoring out a GCF. I am going to go ahead and say that it's going to be the most important method. The reason I'm going to say that is because it's always going to be our first step. So I'll start creating in these videos a flow map or a tree map that describes the method or the progression you should take as you're factoring a polynomial and what the steps look like in each of those, or what the process looks like in each of those steps. So to start with, factoring out a GCF, when we factor, we're rewriting an expression as the product of its factors. So we're rewriting it as a multiplication problem is essentially what that's saying. Our greatest common factor, our GCF, is going to be the biggest number and or variable everything can be divided by. It will undo distributing. When we find the GCF, we are going to undistribute it by putting it in front of a set of parentheses and determine what should be in those parentheses so that if I were to distribute it back in, I would get my original answer. And as I've already said, it's always going to be our first step with factoring. We've already looked at how do I factor with numbers. So if I look at my first example, I see that both 3x squared and 6 can be divided by 3. So when I factor that out, I'm left with x squared plus 2. We've already looked at how this could be a tool for simplifying with complex numbers. So we've seen examples like this before. Now we're going to bring variables into the mix. So if I look at x cubed and x to the fifth, if I look at the definition of x cubed, it's x times x times x, and x to the fifth, and I ask myself, what is the biggest amount of variables that everything can be divided by? I see that both of these, the most amount that they can both be divided by are 3x's. Well, what is x times x represented as? Well, that's represented as x cubed. Therefore, both x cubed and x to the fifth can be divided by x cubed. Looking at my next example, 12x squared and x to the fourth, I'm going to basically do the same thing as I did in the first and the second example up here and here, only I'm going to combine them. So numerically, I'm going to ask myself, what can 12 and 8 both be divided by? Well, numerically, I know that they can both be divided by 2, but the biggest or greatest they can both be divided by is 4. X squared and x to the fourth can both be divided by an x squared. When we look at variables, we are essentially going to take the lower powered variable as our GCF. And now I'm going to ask myself, what should be left in those parentheses? Well, since distributing uses multiplication, I'm going to go ahead and say factoring, or undistributing, uses division. So 12x squared divided by 4x squared is going to leave me with just 3. My x squares cancel out. 8x to the fourth divided by 4x squared is going to leave me with 2x squared. Because if I had x to the fourth, and I divided by x squared, I'm left with x squared, x times x. There's my factored form. So let's look at just a couple of more examples here, and if you want to try to pause the video and try them on your own before you watch them, I think this is a great video to do that on. Step 1, I'm going to factor by taking out a GCF. So 6x to the fifth and 15x squared. Numerically, I know 6 and 15 can both be divided by 3. X to the fifth and x squared can both be divided by x squared. I put it out front and I ask myself, what is 6x to the fifth divided by 3x squared? Well, 6 divided by 3 is 2. X to the fifth divided by x squared is x cubed. I'll show you why in a moment. 15 divided by 3 is 5. X squared divided by x squared is 1. So that's canceling. Here's my most factored form. So if you're asking, how did I know that x to the fifth divided by x squared was x cubed? If you need to, do a little bit of a setup until you start getting familiar with this. If I go ahead and put 5x's on top, definition of x to the fifth, 2x's on the bottom, definition of x squared, and cancel, I'm left with x times x times x, which by definition of exponents, multiplying it something by itself 3 times is x cubed, which is where I got this. Also notice I can check by answer by saying, what would happen if I distributed that back in? Well, 3 times 2 would be 6. X squared times x squared would be x to the fifth. 3x squared times 5 would be 15x squared, so it does check for me. Looking at the last 3 examples here, I asked myself 7x cubed and 28, what can both of them be divided by? They can both be divided by 7. Since 28 doesn't have a variable part, I cannot divide both terms by any x's, so I'm just going to say 7x cubed divided by 7 is x cubed. 28 divided by 7 is 4, and there's my factored form. Doing the same thing on example 3. On example 3, 16 and 48, I know that they can both be divided by 16, but let's say, for argument's sake, I couldn't figure that out. And I said they can both be divided by 4, x to the 5th and x to the 7th can both be divided by x to the 5th, leaving me with 4, x to the 5th completely cancel, minus 12x squared. Well, notice that if I look at 4 and 12, unlike up here where 2 and 5, there's nothing they can both be divided by, 4 and 12 can still both be divided by 4, so I could take another 4 out, leaving me 1 minus 3x squared. Notice I can't say that there's nothing here. It's a form of division, so 4 divided by 4 has to leave me with that 1. From here, it doesn't matter what order I multiply in, so 4 times x to the 5th times 4 is 16x to the 5th times 1 minus 3x squared. So notice in the beginning I had said I know I can take a 16 out, so notice that I will get the same answer either way. Finally, looking at the last example here, I have 9x squared minus 3x. I know they're both divisible by 3. I also know I could take an x out. I know 9x squared divided by 3x. 9 divided by 3 is 3. X squared divided by x leaves me with just an x. Minus 3x divided by 3x is not nothing. They don't just cancel to be nothing. They cancel to be 1. Since anything divided by itself is 1. I have to have that 1 there or my answer is incorrect. And that is it for factoring on a GCF. The big thing is just make sure that you really are taking out the greatest common factor, not just a common factor. So just double check that once you're done undistributing, once you're done factoring, that expression inside your parentheses truly is its least or its simplified form, that you can't take anything else out like we did here.